In this video, we're learning different ways of measure the center of the data. So starting with the mean. So mean has this notation of a line on top of X. So whenever you see that notation, you know we're talking about the mean. And mean gives us the average value. So to find the average, what you need to do is add all of the data together and divide it by how many data values that you have. So let's look at this example and find the mean together. So this data shows you premierships won by each club, and we want to find the mean for all of these teams. So what you need to do is first determine how many teams there are. So you simply just count, and there are 18 teams. So N, which stands for number of data values, is 18. And we also now want to add all of these numbers together as well. So to find the mean, you'll need to add 16 plus 16 plus 15 all the way till the end, where you're adding like all the zeros. Obviously you don't have to include the zeros because adding zeros will not change anything. So you want to add all these up and divide by how many there are, which are 18. And using the calculator or the CAS, it will give you the mean as that. And the next way to measure the center of the data is median. Median is not the average, it is simply the middle value. So it's more to do with the position of the data. So if it's positioned in the middle of the data, that's the median. Because we're dealing with position, we want to make sure that our data is ordered. So it goes from like lowest to highest. That way we know like the middle value, the position is the middle median. So when we have odd number of data, median is nice. It's like one value, the middle value. You simply just count from, I do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, middle. That's the median. However, when we have even number of data, you need to average out the middle two values. So again, we're counting like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 6, and sort of this is the middle. So you want to average out these two numbers. And what I mean by averaging out is adding them together and dividing it by 2. And that's going to give you the median. Now, counting and crossing numbers out is good when the data is small. However, when data is really large, there's a lot of numbers to cross out. It does get a bit hideous, and we do want to have a more efficient way. So please add this to your booklet and your Bound reference. So just following this little formula here. So N is number of data. It says right here. So if you plus 1 to N and divide it by 2, that's going to give you the position where the median is in your data. So this way it's a lot quicker, and you sort of just count where that position is in your data. So let's put that into use and look at this one together. So here it nicely tells you that there's 23 people in this data set, and we are asked to find the median. So to do that, let's use what we just learned. So it's n plus 1 divided by 2. So n is 23, because it tells us that it is. So we have 24 divided by 2, which is 12. Now, 12 is not your median. That is very important. You haven't calculated the median yet. This is the position of the median in your data. So then now you go, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the median. And that value there is 41. You can see the key here and read this stem and leaf plot correctly. So the median is not 12, it's 41. So again, using this will give you the position. That is really important. A lot of mistakes are made thinking, well, I got 12 using this formula, that's my median. It's not, it's the position of the median in your data set. And this next one does not give us how many numbers are in the data, so we do need to calculate it ourselves. I would go about sort of writing it like this. So there's 3 here, 3 here, 4, 4, 3, 2, and 1, and add them all up. And you should get 20. So n is 20. And then to find the median, we want to do 20 plus 1 divided by 2. That's 21 divided by 2. So 10.5, meaning your median is in that position. So you need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you also need to look at the 11th number, because 10.5 is between 10 and 11. So your 10th number right here is 3. So this is for, let's do this properly. So this for the median, your 10th number is 3, your 11th number is 4. So you want to average these two out, which should be 3.5. So that is your median. Again, this is the position of your median. All right, so when do we use mean or median to measure our center of data? So this is a very classic assessment question. So you would definitely need to know this, and it's not that hard. It's very intuitive, it makes sense. So it's to do with outliers. So outliers are numbers that's really far away from the center. Later we'll learn how to actually calculate outliers. If we have outliers in our data, or if our data is skewed, so it's not symmetric, median is going to be the better way to measure the center. So if there's outliers or data skewed, median is the way to go. Might just color coordinate this a little bit better. And that is because median, imagine if there was a bunch of data like 1, 2, 3, 4, and then we have an outlier at 3000, and we use mean, meaning we use average, then we add these up and we get 3010 divided by 5. So we're going to have 602 as our mean, which doesn't represent this data set really well, because it's mostly just 1, 2, 3, and 4. Now, if we're to find the median, which is just 3 here, that does represent data a lot better. So when there's outliers or data skewed, median is the way to go. However, if our data is nice and symmetric and there's no outliers, we can use either. Mean and median will give you a similar or the same value for our center. So really important that you know outliers, median, symmetric, could be either way. So you may notice that, well, medians in both skewed or symmetric. So yes, you should always use median when we measure a center of data, unless it specifically asks you to use mean. Now, finding the median, mean, or all these other stuff can be done on the CAS, and it is recommended that you do it on the CAS. It is a lot quicker, it's a lot more accurate than adding a bunch of numbers by hand. And here's how you do it, and you should try this out on your CAS right now together with me. So go into Home and press this green button with a bunch of tables, or I think you can just also do Control Page or Control Document, which will add a new page, and go to number 4, Lists and Spreadsheet. And then this page will show up. First thing you need to do is to type in what data that you're putting in. So let's just pretend that this is some sort of scores that we're typing. Then type in scores at the top, and then put in the data values that you're given. Let's just pretend that we've got given these values: 10, 15, 20, 30, 40, 50, 60. Obviously, you might have data sets that go a lot longer as well, but let's just deal with this small data set right now. So after putting that in, what you need to do is to go to menu, statistics, stat calculations, and then one variable statistics, because we're dealing with just one variable right now. And it tells you how many number of lists do we have. We have one, so press enter. And then what you need to do is on your X1 list, you want to change this into whatever you typed in, which in this case is scores. That's all you need to do, and then press OK. And then all of this stuff comes up. So this thing here is the notation for the mean. So it's calculated the mean for us right here. So mean is 32.1429. And then this is the sum of all the data, which is not that important, so I might skip over that. What is more important for us in this topic is this one here. SX is the standard deviation, which you'll learn about a little bit later. It tells us the standard deviation as well. Also tells us the number of data, which is 7. Tells us the minimum, median, and maximum. So the highest number, lowest number, and the median. Also tells us Q1 and Q3, which is really useful when we calculate the interquartile range as well. So I highly recommend using the CAS as much as you can. It is very useful.